Okay everyone, today's topic is 555 timer. This is one of the most important topics in your ICA subject. Now, before we go to the actual 555 timer, let me explain what is the basic concept behind the timer. It essentially consists of a power supply and a capacitor which has to be charged. Now this circuit, this part of the circuit has just got a switch. This is switch, SW. Now what happens here is, when the switch is open, that is when there is no contact, this will charge this capacitor. All the supply will come here and this capacitor will charge up to the maximum potential. So it will be something like this. Okay. Now at some time this switch will be closed. So what happens at that time is, all the power supply will not come here because this is a closed circuit. So this capacitor will now discharge like this. So this will go here, right? So this capacitor discharging will be somewhat like this. So now you can expect a output cycle to be like this by this action. Okay, this output is going to a comparator, where the comparator output will be connected to something else, and that we'll discuss when we discuss the 555 timer. So this is just the basic concept. Okay, now let's go to components of a basic 555 timer. Now you saw above that we need a comparator. Here we need two comparators, an SR flip-flop and a transistor. The switch action is performed by a transistor. Okay, I'll explain to you how. Now before we discuss, actually we can discuss this circuit directly, but the thing is, if you discuss it directly, remember that a 555 timer doesn't have independent operation. When you connect it in a circuit, only then does it have an operation. So I'm going to explain this operation to you by considering a monostable multivibrator. I hope you know what is the meaning of a monostable multivibrator. It is just that one cycle, either on or off, you can control the timing of the cycle. Other cycle is indefinite. Okay, this is indefinite cycle, you cannot control. One cycle time period you can control. This is called a monostable multivibrator. So here just follow me. The basic operation is starting from here initially. Suppose that initially the output is high. So when this output is high, what happens? This transistor Q is driven into saturation. When this is saturated, the capacitor, this capacitor C, it discharges like this through here and to ground. So this discharges completely. So the initial charge on the capacitor Q will be equal to 0. Okay, and because we are considering this Q to be high, this output will be obviously low. Okay, so this is the initial state. Now let us start the operation. When we apply a trigger voltage, suppose this is the trigger voltage. Now we are applying a low going pulse. Okay, so up to this point, because this voltage, remember, is how much? It is equal to 1/3 VCC, isn't it? So what happens is, up to this point, till the trigger voltage is up to this point, this will be low, this output will be low anyway. After it crosses, this output becomes high, and this will be how much? It will be reset. So it will become 0, that means output will become 1, because Q bar is the output, remember. So output becomes 1. Now since this is becoming 0, this transistor will be cut off. Okay, and when this is cut off, this discharging action stops, and now the capacitor starts charging from here through the VCC. Okay, now this capacitor charges up to, what is this level? 5, 2/3 VCC. Now when the capacitor, this voltage, suppose this is B, when this voltage goes above 2/3 VCC, this flip-flop S input is again set. When this is set, again this becomes 1, and again the cycle is repeated. So I hope you understood the operation. If not, please go back and listen again. So this is the basic operation of a monostable. So what we are doing here is, just look at this waveform. This is the trigger. When at this point, when trigger goes low, below VCC, this starts charging like this up to VCC, up to 2/3 VCC. From there again I told that the transistor goes to cutoff, so again it is a discharging cycle. So this is will be the output for your monostable multivibrator. Pulse width, this I told you initially that the pulse width can be changed or controlled. So this is our pulse width now, the on cycle width. So this formula is this one. If you can derive this, it's well and good, but it's not important. So just remember the formula, okay? Now, so one thing I told you that this is not the 555 timer doesn't have an independent operation. So remember, this capacitor, this resistor, all these things are not part of a IC, 555 IC, okay? This you have to connect externally. Only this is the basic circuit of the 555, which I'll show you from an external point of view now. Now see here, I have also marked these numbers 7. See, this is 8, 7, 6, 5, 2. This is 3. This is 4. Okay, these are nothing but the pins of the 555. So I'll show you the pin diagram. This is the pin diagram of a 555 timer. It has 8 pins. Ground, you know. Trigger, you know what it is, the pulse that we applied, the low pulse, that is the trigger pulse. Output. Reset is for the SR flip-flop. If anytime you want to stop the operation of the 555 timer, you just apply a reset to SR and it will stop. And VCCs are supplied. Discharge is the capacitor, where you keep the capacitor. Threshold is again the capacitor output, because you have to check with the comparator. This control voltage is nothing but the second comparator reference voltage, which you have seen in the circuit. So let us see this from a external point of view, how the diagram looks. This is, remember, this is the same diagram which I have drawn there, but there it was with the internal diagram. This is only the external diagram. So you can see that this is our resistor R, which we have connected there. This is a capacitor C, which we have connected. This is a control. This control has to go to ground through some capacitor C dash, suppose. Okay, so this is not an important part of the circuit. This is our main capacitor. This is the main capacitor which we are charging. Okay, so this is a simple monostable circuit. It is the same that we have drawn earlier. Now let us compare with an A-stable circuit. Actually, in a similar way, you can explain an A-stable. In an A-stable circuit, what is the difference is the pulse width cannot be controlled. You will have pulses like this continuously. Okay, there is no particular control like we had in monostable. Okay, so the A-stable circuit difference will be, because now you need to have two pulses. So you having two resistors, okay, and a capacitor, and this is the same. This charging principle is same. Only point is you have two control points here. Here remember, there was only one, because there was no need to control the second pulse, isn't it? But in A-stable operation, you will have an output like a square pulse. Okay, just see the diagram once again. Here you will have another resistor. Okay, just imagine that here you have another resistor. So this just makes it A-stable. The operation is absolutely same, but instead of one pulse, you will get two pulses, square wave type of output. Okay, so this is the external diagram for an A-stable multivibrator. Now let's just look at the applications here. These are the applications for monostable. These are the applications for A-stable. Okay, so pulse position modulation, pulse width modulation, because I told you we can control the pulses here in the monostable, so you can use it for modulation. Ramp generator, see the capacitor output is something like this, right? So this you can use for a ramp, like a ramp you can use. Frequency divider circuit, see if you what is the frequency here? The frequency is nothing but the trigger frequency, and the output is some other frequency. So the trigger frequency and output frequency relation you can have like f by 2, f by 4, anything. Okay, so this is the input, trigger is the input, and pin 3 is the output. So you can use it as a frequency divider circuit by taking an appropriate relation. Now A-stable, I told you it's a square wave generator. I already explained how. Voltage controlled oscillator. So if you convert this square wave into a sine wave, this will nothing but a oscillator, and since it is controlled by what? Some threshold, some voltage. So it is a voltage controlled oscillator. Okay, frequency shift keying. This frequency shift keying you will be studying in 3.2. So that time you will come to know how a 555 timer is used as a FSK generator. Okay, all the best.